Okay, 8.1, L'Hopital's rule. Before we get into L'Hopital's rule, let's look at this limit first, okay? So this limit, how do you start the limit? You would not start factoring. You would start plugging it in. So plug it in, and then you get 0 over 0, and then you're sad, and then you realize, ah, shoot, I have to factor. So then you factor using SOAP. So same, opposite, always positive for your signs. And then you have x and a 2. This is x squared, this is 2 squared, this is 2x in the middle. Okay, you used SOAP, cross, cross. And you cancel out one of the factors. You plug in the 2 and you have 4 plus 4 plus 4, which is 12. Okay, that is not called L'Hopital's. That is what we've already learned. So we factor and then we, plug in to find our limit. But then we talked about this stuff. So we highlighted things together, and then we talked about why these are what they are, okay? So basically, any of the highlighted ones, here's why it doesn't work. Are you ready? So the numbers represent any number. So I would plug in like a 5, okay? As like an average run-of-the-mill number, I like to use 5. So 5 to the first power is 5. That's always going to be true, okay? Over, let's say here. So infinity times any number should be infinity. But 0 times any number should be 0. Well, then you can't have an answer. It's indeterminate. Let's try it again here. Infinity to any number should be infinity. Any number to the power of 0 is usually, like 5 to the power of 0 is 1. Infinity and 1 are not the same thing. So I can do that with all of these, right? So like 1 to the power of 5 is 1. So we think our answer should be 1. But 5 to the power of infinity should be infinity. So 1 and infinity are not the same thing. So you can do that with all 7 of those, and you get an indeterminate value. So that's why we highlighted them. So for any indeterminate value, which is highlighted, all 7 of those, we should be able to use L'Hopital's rule. L'Hopital's rule only works for fractions. So it works for this, it works for this. If it's in another form, we can make it into fraction. We can make it into something over something, and we'll deal with that later. In our homework, we'll have some of those. But basically, L'Hopital's rules is, if you have a fraction that ends up being 0 over 0 or infinity over infinity, then you should be able to take the limit of, take the derivative of the top, take the derivative of the bottom. This is different than taking the derivative of the whole thing, which is low d high less high d low denominator squared below. So separately, take the derivative, take the derivative. And then you check it again, and you might have to use L'Hopital's again. So if we're going back to this example, here's what it looks like. So you plug it in, you get 0 over 0. Oh no, that doesn't work. So then you take the derivative on top. So this is me telling myself I'm using L'Hopital's. Okay, so I like to do that. You should do that. You really should. So then you're using it, and then you have a 3x squared over 1, and then you plug in the 2, and you get a 12. Yay! Here's the thing to remember. You cannot use L'Hopital's if it doesn't apply. You can't do L'Hopital's again. 1 out of 100 times you'll get the same answer, but 99 times it's going to be wrong. Okay? So don't just keep doing it. Don't do it if you don't have to do it. You can only do it if you get 0 over 0 or infinity over infinity. Okay, that's it. So if it's not that form, we'll make it into that form. I'll show you how later. Okay, so this one we did not do together, but we started it, and I said, okay, you're going to do L'Hopital's. So you do L'Hopital's, you have to, 2 to the x power. Oh, how do you do the derivative? We've been doing that a lot, guys. So you practice that. So it's 2 to the x ln 2, and then minus 0 all over 1. Okay, now you plug in the 0. What's 2 to the 0? It's 1. ln of 2. Done. That's your final answer. Okay, this one's a little different. You plug it in, you get infinity over infinity. Oh no, L'Hopital's. So then you get the derivative of the top and you get the derivative of the bottom. Oh no, you plug it in, you still get infinity over infinity. L'Hopital's again. Oops, sorry. Let me turn that off. I need to finish in less than 5 minutes. That's what that means. Okay, and then you do L'Hopital's again and you get this. And then now you plug in infinity and you get infinity over 2. What's infinity over 2? Infinity. Yay. Done. Okay, so yes, you do have to use it more than once sometimes. Okay, this one we talked about together. You plug it in, you get infinity over infinity. Oh man, so you do L'Hopital's. So then on top, you get 1 over x. On the bottom, you get 1/3 x to the negative 2/3 power. And then you don't plug it in. You simplify. Okay, so I simplified a little bit. And then, so right, because this is actually a fraction, so you're multiplying by the reciprocal, and then you get this. And then realize this is 3 over 3 power. This is a power of 3 over 3. So then you simplify some more, and then you get this. And then that's something that you can plug into. So now you plug in, oh, that's 0. There you go. Okay, so you only actually had to do L'Hopital's once, and then your final answer is 0. Okay, last one we did together, but that's okay. So yes, you do have to know the tangent of 0. The tangent of 0 is sine of 0 over cosine of 0, which is 0 over 1, which is 0. So 0 minus 0 over 0 is 0 over 0. Okay, L'Hopital's. So what is the derivative of tangent? It's secant squared. All right, we're all good. But then you plug in and you get 1 minus 1 over 0, which is 0 over 0. Oh man. Okay, then you do L'Hopital's again. Okay, so I'm gonna write this out one time so you see it. Secant x quantity squared. When you take the derivative, the 2 comes forward, and then you get a secant x to the first power. And then you take the derivative of secant. What's the derivative of secant? Secant x tangent x. So how did I write that? I wrote it like this. So 2 secant squared x tangent x. So same thing. On the bottom, you get a 6x. I crossed out the 2, I crossed out the 6, and I just put a 3 on the bottom to make life easier. But then when I plug it in, remember tangent of 0 is 0, and then 0 on the bottom, 0, 0 over 0. Damn it. Okay. L'Hopital's again. 3rd time's a charm, right? 3rd time. Okay. This is a secant squared. This is a tangent. When you multiply those and you take the derivative of multiplication, it's a product rule. So check that this makes sense to you. You should be able to do this. Box times the derivative of the triangle plus triangle times the derivative of the box. What is the derivative of secant squared? We just did it up here. It was 2 secant squared x tangent x. All over the derivative of 3x is 3. Okay, the good news is that's a 3. So it's not going to be 0 over 0. It's not going to be infinity over infinity. All right, plug it in. What is secant squared of 0? It's 1. So really, this is 1 times 1 plus 0 times something, which is 0, over 3. 1 over 3. Final answer. Yay! That deserves a smile. Yay! Happy. Okay, so there is L'Hopital's. The big thing, huge thing to remember is, again, must be a fraction, and you cannot use it if it doesn't apply. So only when you get 0 over 0 or infinity over infinity can you use L'Hopital's. Otherwise, you can't use it again. That's not going to be the final answer. All right, see you later.